So, hello everyone. I'm Dr. Lars Ruddigkeit, and today I'm here at Confer speaking about responsible AI in our Microsoft products and how do we handle and incorporate the responsibility to use AI correctly. Actually, I would really start with a quote of our dear friend Bill Gates. Computers will one day see, hear, talk, and understand human beings. Because this is roughly the root cause of how we think about artificial intelligence at Microsoft. When you just think what really intelligence means from the human point of view, it is about all the things that come from vision, speech, language, and also a reasoning that we do from all these interactions that we have with our outside world. So if you think about it, why should this not be the case if we make the same things feasible for computers, like computer vision, language understanding, and even speech recognition and speech understanding, speech to text? And if you have all these capabilities that also let us have interactions with our outside world, also computers will over time really have similar capabilities and maybe even what we really call real intelligence. Furthermore, from the Microsoft, we really start with research in this field. We have around 8 different labs around the globe that have more than 1,000 researchers employed in roughly 20 fields related to AI. We have also roughly more than 4,000 patents, but also more than 22,000 research papers that is sometimes forgotten, but also we do research at Microsoft. And just really to bring it to an understanding, I mean, we have been breakthroughs in the field of artificial intelligence year over year, be it object recognition, machine translation, but also really what we have seen last year was really a tremendous push forward to multi-language translations. And there might be much more examples that I'm just showing here, but just to give you an impression how fast the field is really if you're following it. And it is not only buzzwords, it is really about innovation that brings us forward. Furthermore, let's really make some inputs out of our research. So from Redmond, we have really started to incorporate our own field programmable graphical accelerators, similar to the famous tensors from Google. We also have really done other research for speak recognition, machine translation, but also really object detection and also conversational question answering on a human level. And let's really say it is not about being better as a human. And I really want to emphasize this first with an example. What you are seeing here is a Chinese news article. And what we have done, we have taken this article, have done it with a direct translation using Azure Cognitive Services. And at the same time, we had a reporter translating it. But to be very clear for the experiment, the reporter was not watching the Olympic Games, and he was not aware of all the things happening at the Olympic Games at the point in time when he was doing the translation. So we're reducing some of his things that he can say as additional information and really reduce him just to this piece of text to really have a fair comparison between what he is doing and what the machine is doing. And the result of both translations looks like this. And if you take some time and read carefully through these two translations, you will see that they are very similar and you have really problems saying what is the machine and what is the human. Nevertheless, the important point is here when we call about human parity, both, because we are missing some context, make one mistake, and this is the name bias of the athlete. So if you just have the information of the Chinese letters, you try to translate this into a name. And in both cases, the human and also the machine make a mistake. I mean, if the human would have watched the Olympic Games, remembering how the athlete was called, this would be a different scenario. But really, we want to have it as unbiased by other information as possible for this experiment. And also, just to make it clear, the upper one is the machine translation, while the example below is the human translation. So why I'm showing this and what is the point that I really want to make with this? We at Microsoft start really with AI research. We develop products and really bring these products to our customers, but have really a continuous feedback loop. Because while we create a product, it might not do or behave as the customer wants it to behave. So really important that we really get back the feedback from the customer, even back to research. And also to make this very clear from what we see as the evolution of companies. We already see for some time that every company is becoming a software company if you're really looking anything that is bigger than, let's say, the bakery around the corner. And as a consequence, because AI is becoming, let's say, a commodity for certain use cases and for certain scenarios, we really see that every company is either already what we call an AI company or is on the verge to becoming an AI company. Nevertheless, what is it all about? We have a tremendous amount of information, and it is really important that we can connect this information to get meaning out of it. If we really look at computer systems, like we are doing it ourselves unconsciously, we really don't try actively to remember things. We have learned things and we try to interact on all the interactions that we have done ourselves over time. The reality, if you look at companies, is normally really data silos. And as a consequence, connecting of data silos really means also that the artificial intelligence is limited by the number of connections it can do inside of a company. When you're really looking at real world scenarios and not as, let's say, fluffy small data sets. Out of it is really make this everything available in a perfect world scenario. Connecting the information and the dots means we are empowering employees to make really good decisions. We also make the engagement with our customers much more feasible and more human-like because we bringing all the context that we as a company have with a customer into it. And it is also about optimizing our process because only if we understand on a databasis why something is not performing well, we can optimize it. It is not about blaming problems. It is about finding out of the information available why things are happening. And really, as a final consequence, it really means a transformation of products and processes on how we interact as companies with customers. And in the end, the customer is the one who decides. Here's the magic power called his wallet if he is willing to take the service, yes or no. Nevertheless, if you really look what is this as a consequence, it is really about not doing just AI, it is about putting AI into action, really empowering people, but also have a responsibility to act correctly based on it. It also means about solving problems that we have today and also problems for the future. And it is also about reimagining how we interact with the world and also with the things that we are doing, because we need to scale out for this on AI and really go to a level that every employee can do his best based on his own skill level with supporting systems, but also going to autonomous systems like self-driving cars, as an example. If you really look, nevertheless, just a little bit not so optimistic at everything, it is really about maturity in analytics. I mean, many companies already know what happened, how many sales they had in the past. And also some of us really have supporting material and data and know why did it happen. But when it comes really to the clear predictive power of saying what will happen, meaning, for example, if I do this advertising campaign in this way, I'm absolutely sure that my sales will go up by 20.5%. And not just saying it will go up. I mean, really, this campaign will perform better at 20.5 versus this other campaign will only work at 15.2%. It is really about being precise in your predictions and really what will happen. And nevertheless, if you really would be in an optimal level, and believe me, this is dream versus reality, in my opinion. It is about really optimization. What is the best that could happen if we have all the information available and could do the absolutely right decision? Nevertheless, to be very precise, artificial intelligence has really applications across industries, functions on various occasions. I just want to say it is really omnipotent in everything that companies do in our time. And there's always the question between what our companies are focusing on and what they are really admitting where they are using machine learning to help their company to perform better. For the next part, I really would also like really to have a quote from our dear CEO Satya Nadella. We are pursuing AI so that we can empower every person and every institution with tools of AI so that they can go on to solve the most pressing problems of our society and our economy. So from a Microsoft point, it is about empowering others with artificial intelligence. It is not only about what we can do inside of our company, but really how to empower our customers also to use AI. From a practical perspective, this means really AI across the organization. It really means what we would call embedded AI for something like translations in Teams, for example. It really goes to, let's say, citizen developer driven tooling in the Dynamics platform just to build, for example, business workflows out of a box. But it also means really advanced business roles really to interact automatically with chatbots, but also really going to hardcore Azure machine learning systems where you make your custom models. But the big difference is really the solutions being off the shelf versus fully customizable by the customer. And has really consequences how you think about it. So if you really just go with a plain example of Microsoft Teams, you have a possibility to have directly in-text translation of something like, for example, Arabic letter communications. You have an automatic possibility to record a meeting in Teams and also make a direct transcription and a summary out of what was discussed in the meeting. And the one that really customers don't think about AI is really about the background change in Teams to have, for example, a new background picture like an office, but also just to blur it because you don't want that they see your colleagues or what your colleagues are working on it. So this is really just bringing AI on a very practical level without the person using it realizing it is artificial intelligence. And this really goes on that we have really various projects and various levels across it. And I don't want to go really on all the products, but really emphasizing some products are really fully embedded by the end user and they don't realize it. Whereas some of them are really made for IT developers and others really for data science. And you can have really some overlaps of it. But when you really think, for example, about a very common problem that, data scientists are bothered with, is, for example, OCR. Can you extract me standard information out of a PDF? Now, from a Microsoft perspective, we have seen this across hundreds of customers doing all the same problem. And this really sparked the invention of what we have a service called Form Recognizer, meaning a standard tool where you just have a GUI to select which features you want to extract. And later you can make automatic processes out to extract information out of PDFs. And really just on an IT developer perspective, not any big data science knowledge about OCR. It is not needed. It is really like, here's your thing, make click and drop selections. Please prepare it. Out of all the key values extracted from a PDF, these are the ones you want to forward to a database. And this is really keeping the end user in mind and not just, oh, I'm sorry, I just need, again, a very costly data scientist to bother him with extracting key values out of a PDF document. And it is really like from the top to the bottom, there's really the difference between roughly no knowledge about artificial intelligence, machine learning, statistics, you name it, versus that you need to be an expert if you really do certain things with Azure Machine Learning Platform and really want to have fully fledged customizable solutions. Nevertheless, the reason why we are talking here is not about meaningful information or empowering people. Today, we are here really to talk about what we call at Microsoft responsible AI, versus other people would call it ethics in machine learning, or what we really need to change in machine learning to bring it to something useful and good for the society. So we really have to make this clear. For Microsoft, responsible AI is very important, and that's why we really try our best to incorporate it completely in all the products that we use ourselves and make available to our customers. But really, it is a very interdisciplinary field if you really look at it from a pure perspective. It is not so much about technology. It is about ethical principles. It is about what governance and operations expect of us. It also means about tools that empower others to do the right thing, but also about public policy. And here the big problem is it is not, let's say, binary, yes or no. It is about what we call ethic values as humans, and these are also not set in stone. Ethics values can really change over time. And this is really something that makes this field very interesting for us at this point in time, but also makes it very challenging and very interdisciplinary to work with to bring it to what we need and want to achieve here. So, to give you really some insight on the background of how all this started really as Microsoft. It really started in 2016 when our CEO was writing a paper about the concepts of responsible AI and what we roughly need to change. And just really to bring something into the background of people why this might happen with a CEO. Our CEO has a child with disabilities, meaning he has a compassion that is very high and also means that he looks at problems a little bit different compared with a person that never had to struggle in life. So he is really having first-hand experience with disabilities, and that's why he really was having much more, let's say, personal relations to ethics, really to see how we behave and include others in our world to work with us and also to make their life easier. So in 2017, we formed what we call the ETA committee, and this is roughly ethics and AI and also engineering. So we bring together people from engineering, machine learning, legal, compliance, and also really just people that you would call philosophers together into a committee to say, look, we have now understood that there is a challenge. We make a lot of decisions by machines that are black box, and we just want to trust it. But what does it mean to trust a machine to take a decision? And there have been really examples in the past of blind trust into something that just nobody understood. So, to be honest, not much difference when throwing a coin or just saying we found it in a book that is religious. So out of this, we also have published in 2018 really our first AI principles for the future of computed. We also made really an official call to the regulators and say, look, there must be something that really brings a demand for regulation of it, because artificial intelligence is not magic. It is really something that is based on what we bring into the system, and that's why we are still accountable for it. And it is not like that AI just magically will solve our problems just because it is a computer. And while computers are based on binaries, yes, no, and also some fractions between, they are still based on things that we tell them to do. And meaning this, computers are not, let's say, unbiased. Out of this, we really have also invested in 2019 really to really define persons that are really what we call champs in this field of responsible AI. And we also made a whole office for responsible AI in a spoke and hub model available inside of a company. And out of this, really bringing the ethical knowledge centralized, accountable to all the teams that are working in AI in Microsoft. And we also published our standards for responsible AI very transparently that everybody can read after if he wants to. And we also really have brought what we call responsible AI strategy in engineering. We really a practice that looks at it how we train and design our models and really bring it to the standard that we, at least at this point in time, can achieve. Because really it is a dynamic field. It is not set in stone, and it is really something that is advancing. And also, we really have published all the standards. And what you will not see here on this timeline, because it is currently happening, we are also making the tooling for doing this decision, analyzing these things available. And I will show you more of this later in the talk. So when it comes to, let's say, really our principles at Microsoft, we really want to have AI systems that treat people fairly, in fairness. And this can, for example, mean that people of all races will be recognized by our face API, and that we are not ignoring that, for example, certain ethnicities are currently less good detected due for various reasons. It also means that people can rely on the safety of our systems, that we really work as we intend, always as we are intended. But also, if AI comes to the broader audience and is really used much more, it also becomes an attack vector for cyber attacks. So we also must be sure that all the AI systems follow best practices of security and privacy to be really not being the next big blow up of data in this world. Some also principle that is very important is really inclusiveness, because many people in this world live with disabilities, and AI can help them to be more involved in our society and also make their life much easier. Just, for example, to bring this to a very simple point. Children and also some people with disabilities have problems in reading. We can make systems as a product available that, for example, enlarge directly the screen of a text, show them what is an adverb, what is a noun, and also really just highlights things not as a full text, but line by line. This sounds to be very simple to most of us that don't have disabilities, but it is a game changer for people with disabilities. And it is also really about transparency, making clear what the model does, how it does, and why it works in certain behaviors. And really, finally, really taking accountability. The peoples working on the AI systems have to take accountability for their models and how they behave. And this is, to be very sorry, not always reality. Sometimes people says, "Oh, look, dear customer, this was just predicted by this model. This was produced by another third company, experts in AI, and actually we don't know why you don't get the loan." And this is really something that we believe should change in the future. So while we have now talked about first about the principles of this, I mean, principles must be put into action. And really, if you just look at from a practice point of view, it means really that you give guidelines really about how conversational AI works, how really human AI interactions work. Also, how should you design a system that use AI? And also really to make very simple checklist if your system works as intended. I mean, this sounds a little bit boring from a pure data science perspective, but if you really look at it as a complete set of things we want to achieve, sometimes a simple checklist is a good starting point to see if it works as it works, and really to bring it on like, what do you want to achieve? Nevertheless, this is fine, but it also means we try to provide tooling to our teams working in these things. So really that they understand how something works, really that they can protect also the customer and also themselves from strange decisions because they have not been realizing it before, but tooling makes it available, and also really control this. And really, just from a pure governance perspective, it really means we have people and governance bodies involved in deciding if we take this AI model to the next level. And if we really make a change, for example, to Azure Face API in production available to our customers, yes or no, based on all the things that we have checked before. Now, I really first want to give you some ideas what can be going wrong to a certain degree, because nobody wants to talk about the things normally that goes wrong. And I think personally, really, one of the best examples is really an article of 2012, where it was found very nicely on the front page of a Wall Street Journal. This company was showing higher prices to the customer based on if he was using a Mac system or a standard Windows PC. And in the media, it gave first a big uproar. How can they do this whatsoever? Why? To be very plain, frankly, I think this is really, for me personally, the starting point of why we need ethics in machine learning and why we should not just say there's a model running. But also to be very clear, I think this example is not about being unfair. I just think it's really one of the earliest example that is really visible to the broader audience in machine learning. Because it was not adjusting the price based on if you're a Mac or a PC user. It was just saying if you're a Mac user, you are normally interested in hotels with a higher quality, meaning higher prices. Versus if you normally cannot afford a Mac in the year of 2012, it roughly means you are looking more for maybe still good hotels, but not really the best ones because you normally cannot afford it. So the algorithm works in a way that it really made your recommendation better for you. So that's why I'm saying this is not really about unfair, but one of the first examples that is coming from the field. Nevertheless, to give you really a small example next, what can be really unfair is something like this. You have an automatic system for doing something like you want to make a contract whatsoever, and the system tells you, thanks you for uploading your picture, please open your eyes. Per default, let's say white European American people have big round eyes, whereas Asian people have a little bit different eye shape, which can recognized by the system as closed eyes. So if you really look at the picture, you will agree he has his eye open. So the question is really, should he now really try to make extremely open eyes as a European, or what is here behind it? So there's really just an example that can go wrong and is just unpleasant if it happens and goes into the news. But also there are examples that are much more severe. Here's another study of 2019 showing that they have looked at an algorithm that makes decision how a patient is treated, and we really found a big bias in this algorithm that treats whites and blacks completely differently and not based on what you would call really symptoms. One big bias comes from that they are in the system labeled as he is a black, he is a white. And the companies, the hospitals, and the insurers claim we do best decisions based on algorithms, but they never understood it till somebody was looking into it and was telling them, nice that you are claiming you do this on economics and outcome reasons. We cannot find evidence. And you can imagine this really brings a discussion that is very unhappy in the society. It's like, I'm treated unfair just because I'm black by an algorithm. But really, to give you also the last example that was also very big in the news, is this one about the Apple credit card going live. And the headline in the BBC News is roughly, it is the sexiest credit card and you are under investigation by the regulator. Because, what happens here? I mean, and you even see there was a famous tweet by Steve Wozniak, one of the founders of Apple. Meaning, if you apply for the Apple credit card at the version 1 of the algorithm going live, you put all the fields in like my bank account, my credit history, whatsoever. And the algorithm roughly says you having the exact same values, but being man versus woman, the man gets a 10 times higher limit versus the women. Everything in values putting into the systems equal, not being distinguishable between persons. Just having let's say I'm a female person, I'm a male person based by the name. And you can imagine this is really hard to distinguish why a woman having same income, same credit history gets 10 times less limit. And the reason is really about the data that was used to train the model. But really, this is for me really the best example that was big in the news, showing that we have to rethink about we use machine learning in production. And also to bring it back to the first example. The first example made a recommendation. You, as a user, decided to take this photo, yes or no. So the decision was with you. Here, the decision is taken by the algorithm and you have no choice as a human. And this really shows the big problem of unfairness in AI. Nevertheless, if you look at machine learning in real life, it really goes to various questions that normally are not really openly discussed too much. It is really about which features model should I use? Is my model good? How can I improve the model? Do I really trust this model to be handed over to business? When really, from the business perspective, should I let this model be deployed? Is this model biased or racist? Are the predictions made really matching experts' insights? Are we really behaving as we intend? And also, when really from the end user, why does this model say it? Can I trust this prediction? Is this really right that I get rejected in my application? Or is it right that I was rejected? So, really trusting also the decisions out of end systems. And if we really want this to a practical level, it really means we need to perform certain tasks. We need to identify, diagnose, and if possible, mitigate and detect the problems that we have. So it really starts about, let's really first check, is there is unfairness? Is there is a different behavior in groups? If yes, go to the next step. If everything goes right, fine. You don't need to diagnose and or later to mitigate. So if we really start with the first stage of identifying problems and challenges, if you just look at metrics and really say, my model is accurate, and you will find a lot of articles and also research paper, I'm above 90% prediction, la di la di da. The big problem here is you reduce information to one value. And you normally have this very nice 4x4 charts, rightly yes, right, and not predicted yes, no, correctly predicted no versus not predicted correctly no. And really just bringing this to one value. 90%, 73.8% are really accurately predicted. Nevertheless, if you really bring it to another level and just say it is not one value, you can really see groups and let's say regions in your data set that behave differently. You might have some areas where it is really matching 100%, but for certain categories, it might be only 42%. So really going a little bit deeper and see how does this behave correctly. And really what we mean by this is really what we call, let's say, a cohort analysis. Can you split your data in cohorts and see how these cohorts later behave in the system, really labeling them? And a simple cohort can be men and white, men and women, or black and white, Hispanic, Chinese. So bringing really real life evidence on your data set and really see if there is a different behavior. And really good models, in my personal opinion, will treat equally. But very often in reality, they behave biased. And if you're really first aware that certain cohorts are treating differently, you must see why does it happen and really go into it. And it can be very simple. It can be an example where a voice system fails to recognize the words of a woman versus a man because you have more voice recordings of men. The same might be true for the application in the screening of a job or for a loan, because in the past, less women have applied for this type of job. You have less data on them. So the algorithm might be not so good for the women, while your overall success rate with algorithm is very high. So really, I want to emphasize it is about avoiding negative outcomes of our AI systems for different groups of people. And really, the reason is a bias in our data with which we train our models. Just to really emphasize, fairness is an increased understanding of fairness is really about bias. It is really about group fairness and also how various groups have a variety in the prediction. It's also about making this simply available in visualizations because we are human beings, we look with our eyes. So having just values is nice, but really a dashboard showing for this category it is underperforming makes life easier. And really, this is a starting point also to mitigate it. And as you can see here, the male versus female looks great, but also it is really about the disparity in accuracy versus disparity in predictions. How often does it right versus wrong? And really, it is very simple to evolve on this. Nevertheless, if you are first really have identified, yes, Houston, we have a problem. It is about going one step further, really diagnosing why does it go wrong. And this really goes about understanding the models on various data and really doing benchmarking against. Now we split the group in age groups. Now we do it by gender and really look how does this perform and really do a model assessment. And also really sometimes manipulate your data cohorts to see if something changed and how to bring it to a better level. And really bring support for different feature classes, really to see what feature does for this cohort bring the result to a really not a real world usable example. It also really is about, in the end, about really, as stupid as it sounds, about interpretability. It is changing our black box understanding of machine learning models to really say, oh, it is a glass box. I know it is going wrong for you because you have this combination of features and in this category, it is going just wrong. And it is really about making this available to the data scientist making the models to say, look, I have done an analysis of your model. And look, here in this category of persons, it is going wrong. And I can even detect and bring it back to the level of this feature is responsible. And it is also really about, really from a business point of view, what if? What is really the underlying root cause? Can we really make models that work with any machine learning and really also work counterfactions, really work scenarios to see, I don't only know it works on this data that I have, but let's really come up with artificial persons that I can imagine. What is their combination of data and really say, if I would create this type of persons, how would I behave my model? And this goes into the area. If you, for example, have a data set that you could have trained before only on many white persons, but very few black persons, just introduce some magic black persons into the data set. And say, for example, I now create artificially for my data set Michael Jordan, a well-known black athlete with a lot of income, and see how does he behave in my loan application. And it's really, in the end, really to be very sorry and simple, it is about debugging our model predictions. It is about really make us responsible for our model-driven decisions by the end user. And really come to the point not saying, I have trained this model, hand it over to business, now it is their responsibility. It is really about working together with the end user and the business, really think, look, we really have looked into this model. We really have taken steps to understand why it might not work for certain customers. And not just say, guys, here's my model. It is black box. Now you take care of it. And this is really what we have talked before about really accountability and transparency as the root cause of it. Nevertheless, there's also the thing about mitigate, protect, and decide on the things that you have found. Oops, what is happening here? Sorry, there was something. Sorry, one button was maybe going wrong. So it is really about these things that we call about smart noise. It is really about bringing privacy into data sets. Because we, for example, at Microsoft believe you don't need to see all the real data to make real decisions. Sometimes adding noise to the data will protect the privacy of a person and still let you work with the data and really brings this to a level of privacy by design when we work for machine learning models. It only is something that we doing now, but we also think this is something that we all should do in the future. Because it is a data science, he needs access to the data. It does not mean that he must see always the real person behind the data. And if you think about it, if everybody tells you, look, you must be completely naked so that our products work for you, maybe not so nice. If somebody tells you, look, in my case, you can come dressed and we can still make work with you and your data. This is about introducing smart noise and why it is a good way to bring this further. And also, it is really about bringing the fairness into your model. Really see the differences between disparity in predictions versus accuracy and really make decisions on based what you see and also how this behaves. And it's also about what you also have seen some colleagues talking before about causal inference. Understand overall causal effects and really explore the individual case and also find sometimes treatments to solve this. So everything works together. It is about really about all the steps being combined, about identifying, diagnose, and also mitigate and protect the end user from models doing wrong stuff. And if you really just look at from a very stupid process point of view, to summarize it, it is really about an as first assessment. Is my model fair or not? Does it behave wrong? If you have a checkbox, it works as we planned it. Perfect. Don't do anything more. If it's not going right, go with cohorts, analyze performance of individual parameters and groups. Really explore your data sets and see why is my model data biased and as a consequence my model. And also really use aggregations of feature importances and really bring this to how we contribute to overall performance and really go really to individual feature importance later to really drill down why this case go wrong and really start with experimenting what if I introduce new type of interactions, new persons, new personas into the system? Does the model can it handle it? And sometimes really thinking about real life, like Michael Jordan, can have good impact on it. And in the final stage, really try to mitigate unfair observations in your model. Really bring it to the level that it is really usable in real life by the end user systems and partners. Nevertheless, I've talked now a lot about principles, what to do, what and how. I really want to give you now a short showing what this means in real life and how this can be done. Nevertheless, we are running out of time, but nevertheless, this is how these things are done in practice. And really, there are more information at Microsoft about if you go to aks.com MS Ray resources. But also really from a practical point of view, we are just incorporating at the moment this into Azure Machine Learning as a preview feature, and it will be going GA very soon. But nevertheless, you also can just go to responsible AI reviews and really go to the open source tooling available to you. So meaning it is not only a Microsoft product, you can download these things as open source contributions. And by this, I really thank you, and I hope you enjoyed it, and you have also seen some insight into what responsible AI means at Microsoft. Thank you.